Now moving on with the next example here, what we're seeing, and I've posted this on the web for you, is a calculation based on a proportion test. And a proportion test similarly is a Z test. So calculating the p-value for a Z test of proportion. Now if we're looking at this problem here, we're looking at the claim. Does this provide evidence to support the claim? And this claim is that 60% of people given a new treatment will benefit from it. Now in this claim we're looking for at least 60% as being our research hypothesis, at least 60%, because we wouldn't mind if more people benefited from this treatment, but we'd be concerned if fewer than 60% benefit from the treatment. So of course we're considering here an alternate hypothesis, which would be p is less than 0.6. At least 60% means the probability proportion value would be bigger than or equal to 0.6. So when we're looking at this, the hypotheses then, using our idea of removing the implied equals statement in order to get the alternate hypothesis, we can write the alternate hypothesis is the proportion is less than 0.6, and the null hypothesis would be that p is equal to 0.6. Now recall that we are looking here for the area below 48%, that is the 24 out of 50, 24 out of 50. This means 24 out of 50 is the sample proportion, p hat, and that sample proportion, 0.48, is the decimal value for that. So our p-value in this problem is the probability that the sample statistic is less than 0.48 in the normal distribution with a mean value of 0.6, the hypothesized proportion, and a standard error measure given by the formula p multiplied by 1 minus p divided by n sample size and square root. So this sample size of 50, in this example, our standard error measure is given by the square root of 0.6 multiplied by 1 minus 0.6, which is 0.4, divide by 50, and then take the square root of that, which we can use. I've approximated here to 2 decimal places, but of course using Excel means that we can keep the accuracy of our calculator figure within Excel. So we're looking here for the probability that our sample statistic is less than 0.48 in the distribution with a mean of 0.6 and a standard error about 0.07. Now this next slide shows the information which I've given inside of the Excel distribution. So this is the probability that we're looking to find, and the functions that we would be using for this, the normdist function. In this example, in the file on the web page, I have calculated using cell references the mean, which is the proportion, and the standard deviation or standard error. So the mean is the hypothesized proportion, and the standard error is the calculated value. Standard deviation is the standard error. And inside of those cell references, we have B4, B1, B5, and using true or cumulative, remember that true can be replaced by 1, then what we're considering here, the p-value in this example, is 0.042. So looking at this information on the screen, you can see this Excel spreadsheet which I've given you on the web page. These values inside of the pink cells, if you use those values and change the numbers in the pink cells, use the pink cells to change the sample sizes, to change the details, and the proportion, the standard error, and the p-value are linked to the pink cells. So you will find this quite useful as a way of helping you to determine if your calculations are correct. The p-value will be 0.04. Now recall in this example, and just to make one more point about this example, that is that we're using this for a test where the p-value is on the left-hand end of the distribution. In this example, the p-value is this area shaded over here because it's based on the null hypothesis that the proportion is equal to 0.6, and the alternate hypothesis is that the proportion is less than 0.6. So the p-value here is a left-hand end probability. If you were calculating the probability for a right-hand end p-value, then of course you'd have to subtract from 1, as in my previous example. So you can use this Excel file. I've posted it on the web for you to practice the tests and see what the values will be. But you should understand how those values have been generated within that Excel spreadsheet, and you should be able to do that for yourself without the spreadsheet as a prompt. And you also need to know how to interpret this p-value. So that p-value interpretation, 0.04, remember what this means. It means that if we have the p-value of 0.04 means that we would reject the null hypothesis if alpha is equal to 0.05, which was in this problem. We would reject the null hypothesis because this p-value is smaller than 0.05. But if alpha was equal to 0.01, we would not reject. If alpha equals 0.01, this is a do not reject the null hypothesis. So it depends always on the value of alpha in the test. If p is low, null must go by comparing it with the alpha value. So in fact, when we're considering this solution, the solution for this p-value test, which I've covered there on the slide, if you want to see this worked out and on the template, you can find that on the web page, very clearly stated. But we can also make use of this Z test for proportion, and I'll go through this again just to bring this all together. Our null hypothesis here is that the hypothesized proportion is 0.6 compared with less than 0.6 if fewer than 0.6 or 60% of people benefit from it. This is a Z statistic, so it's a Z distribution, and our p-value is over here on the left-hand end. This is the p-value. The p-value, remember, is the probability of getting a test statistic at least as unusual as the one we find. So our test statistic is what the p-value is based on. This is a Z test statistic, which the formula for a proportion, p hat sample proportion minus hypothesized proportion divided by the standard error, which is p naught times 1 minus p naught divided by n, all square rooted. So that formula leads us in this example to 0.48 for the sample proportion minus 0.6 for the hypothesized proportion divided by the square root of 0.6 times by 0.4 divided by the sample size, which here was 50, and that calculation comes out with a top line as negative, of course, this is a value on the left-hand side, minus 0.12 divided by 0.069 to 3 decimal places, giving us minus 1.73. So notice here, to consolidate this, this is a Z value, which is on the left-hand end of the distribution. Recall that 0 is in the middle of this distribution, and it's a Z distribution. So our probability that Z is less than minus 1.73 is equal to 0.042 using the tables or Excel as in that example. So this is To use Excel means we don't have to go through the calculation of the test statistic because that is done all within the Excel file.